Welcome to Hartman Math. This is lesson 3.5. We're going to do some factoring practice in advance of a future lesson where we take cubic functions in standard or polynomial form, put them into factored form so that we can graph them. So we're just taking a look at a cubic x to the third, so degree 3, cubic expression. We want to factor it completely. So our number one factoring strategy is always GCF. Is there a greatest common factor? If so, let's factor out the greatest common factor. We want the greatest. We want the biggest. So in terms of coefficients, they're all even. So I think we can factor out a 2. And they all have at least x to the first power. So we're factoring out a 2. Factoring out an x. GCF goes outside. We now do parentheses. We do not do anything besides GCF in step number 1. So 2x times what makes 6x squared times what makes 6x third, 22x squared. 2x times what makes negative 8x. We're factoring out a 2 and an x from each term. We should get 3x squared plus 11x minus 4. It says factor completely, so we have to investigate whether we can factor this. We've already taken care of GCF, so we're now going to factor this into a product of two binomials. Set up the parentheses. Keep the 2x. In the fronts of our parentheses, what times what makes 3x squared? We need an x in each. So it's a 3x and a 1x. That makes 3x squared. Now let's think of different ways of multiplying and getting negative 4. We've got 1 and negative 4, 2 and negative 2. So we're going to see what works here. I don't think it can be the 2's because we do have to get an even middle term here, and if we do both 2's, then we're just going to get even. So I think it's going to have to be 4. If we put the plus 4 here and the minus 1 there, I think that's going to work. So let's just do a quick check. Outside, inside. Plus 12x minus 1x makes a positive 11x. That's as far as we can go. The directions say factor. It doesn't say anything beyond that. That is our answer. Box your answer. Now go ahead and try the your turn. Pause the video here until you work it all the way through. Make sure you factor complete. This one also has a GCF of 10 and x. 10x is the GCF. Factored out of the trinomial, 3 terms. We should have 3 terms in the parentheses. Don't go straight to this. Definitely not ready for that. 7x squared plus 19x plus 10. Maybe that's as far as we can go, but we definitely have to try. As a trinomial, factor that into the product of two binomials. Parentheses, parentheses, keep the GCF. 7x and 1x. Different ways of making 10. 1 and 10, 2 and 5. If we put a 5 there and a 2 there, that's how we're going to get the 19x. 14x plus 5x makes 19x. Answer. Example number 2. We've got a function that's a cubic function. Factor this completely. The answer should also be a function. So we're going to look here. We're going to say p of x equals and try to do GCF. Clearly 3 goes into both, so factor out a 3. Factor out an x. The GCF is 3x. 3x times what makes our first term? X squared minus 4. Maybe that's it. Maybe we can keep going. This sure appears to be a difference of squares. Difference, x squared. It's a square. It says it in its name. 4 is a perfect square. We know that. So we can break this up. We can factor this into the product of two binomials. Looks like our last one. It's just a little special. So when we go, how do we make x squared? That's x and x. The fronts have to be the same. You cannot have a 2x and a 1x. It has to be x and x, or 2x and 2x, or 5x and 5x. In a difference of squares, fronts are the same. Backs are also the same. So what times what makes 4? It's got to be the same number. 2 and 2, one's a plus, one's a minus. Doesn't matter which one's which. There's our function. P of x equals. We factored completely. Box your answer. That's a function. Your turn on this one. Pause here until you've got the function factored completely. We're factoring a of x, the GCF. There's no coefficient here, so no number, but x in common. That is our GCF. Factor out an x. X times what makes x cubed? X squared minus 100. That also looks like a difference of squares. Difference, x squared. 100 is a square. So like this one, x in front. X and x, plus 10 minus 10. That's as far as we can go. Box your answer. One more for you. Pause here until you've got g of x factored completely. So our GCF is, again, 3 and x. We have a trinomial, so it's not going to be a difference of squares. Trinomial, x squared plus 2x minus 24. Trinomial, we still factor into the product of two binomials. Two sets of parentheses. Keep the 3x. How do we make x squared? X and x in the front. What are pairs of factors of negative 24? We've got 1 and negative 24, 2 and negative 12, 3 and negative 8, 4 and negative 6. We have to try them until we find the winning combination. I think the one that works, plus 6 minus 4. Then we get negative 4x plus 6x makes a positive 2x. Box our answer. That's as far as we can go. That's it for today. I'll see you next time.